Welcome to the part 3 of our tutorial in Java programming. On this video, we will discuss about the mathematical operators in Java, the operator precedence, the printf function, and basic typecasting. Okay, so let's start. In Java, there's different mathematical operators that we can use for computation. So the basics are the addition, subtraction, multiplication, division, and the modulo. The modulo is the percentage operator. It gets the remainder of a division operation. So let's look at how these operators do on the values. So int num is equals to 10 plus 20. Num1 is equals to 6 minus 15. Okay, so num2 is equals to 5 times 6 or 8. Okay, so num3 is equals to 10 divided by 3 or 11. Let's try 11. And num4 is equals to 11 modulo 3. Okay, then let's try to output these values. Okay, so num, we can copy this. So num 1, 2, 3, 4, and 5. Okay, so we only have 4 variables. Then let's run. Okay, so the result of addition is 10 plus 20 is equals to 30. 6 minus 15 is negative 9. So be careful on the ordering of the values in the subtraction. 5 times 8 is equals to 40. So division, 11 divided by 3 is equals to 3. Since it is an integer, we have a value of an integer, which is 3. It discarded the remainder. So to get the remainder, we have used the modulo operator, so that's why we get the value of 2. Okay, so that is the basic mathematical operators in Java. Next, we need to discuss about the operator precedence. Okay. So Java programming language follows the what we call is the okay, so PMDAES, or parentheses, multiplication, division, and modulo, and addition, subtraction, and last is the equal sign. Okay, so let's delete it first. Okay, so what does it mean? So it means that operators behave if they appear in an operation that has a multiple operations on it. So for example, you want to compute something like this. So 48 plus 6 minus 2 divided by 8 plus 1 plus 4. Okay. So if we have an expression like this, which consists of multiple mathematical operations, Java will follow the PEMDAS rules. Okay? So it will start by, okay, so I forgot the multiplication. So multiplication. So it will follow the leveling of the operator precedence. So if the open and close parentheses do not appear in the expression, the next rule will be executed based on the level. So the next one is the multiplication, division, or modulo. Since we have multiplication and we have a division, the application of operation will be evaluated from left to right. So the first one will be 6 times 4, and then next will be 2 minus 8, or divide by 8. Next, addition and subtraction. Again, it will apply left to right if there are multiples of it on the same expression. So once the multiplication and division is done, whatever the result will be added by 48, then minus, and then added again last by number 4. Now if we print this, let's look at what is the result of this expression. Then press run. Okay, so we have the value of 76. Now how can we confirm if that is the correct result? So let's open the calculator. So as I said, the operator precedence will execute first based on the PEMDAS rules. So 6 times 4 first, and then so 24. Then we have the 2 divided by 8, which is 0.25, or since this is an integer, it disregarded 0.25, it will be 0. So we have 6 times 4 already, which has a result of 24. Then it will be computed on the addition part, which is 48 plus 24, which is 72. And then the last part will be minus, so we have a 0, the result of 2 divided by 8. So 72 minus 0 is 72, plus 4, which is 76. So that's why we have a 76 value. Now, if we apply the operator open and close parentheses, we can change the order of execution. So if you want to compute first the 4 minus 2 before anything else, you can put it. You can also put parentheses on the other part of the expression, and then the left to right operation will be applied also. So this one, the 48 plus 6 will be executed first, then 4 minus 2 will be executed second, then whatever the result of these two will be multiplied, and the product of it will be divided by 8 and then added by 4. So let's run this if the value will be changed. Okay, so we only have the 17 as the result. So let's check it again if that is the correct result. Okay, so we have first the 48 plus 6, which is 54. Then the 4 minus 2 is equals to 2. So 2 times 54 is equal to 108 because of this multiplication. Then divide by 8, so 13. So we ignore the 0.5. Then plus 13 plus 4, which is 17. Okay, so that is the operator precedence. Now let's try the printf function and what does it do in the Java. So let's clear it first. And the printf can be found in the class system. So type system.out.printf. So we have 2 parameters here. Okay, so let's say you have a variable that is of type double and you want to compute the average. So 98.7 plus 85.67 plus 78.90. Then add a parenthesis and then divide by 3. And let's print it out using the print line first just to compare. So average is the average. Okay, so let's comment this and then run the program. Okay, so we have the average. So as you can see, it has a very high precision. It has 14 digits after the decimal point. Okay. So what if you want to print only the two digits of the value, the first two digits after the decimal point? So let's say 87.75. So to do this, we can use the printf. Okay. So let's use the printf. Okay. So let's put first the average and the message. Average is now in printf we are using a placeholder operator, which is the percent sign. Okay. So this is the placeholder. Okay. So when Java encounters the percent sign in the printf context, it will use this as a placeholder for the value, that was whatever value in the right side of the comma. Now the placeholder has a following format. We need to print only two digits after the decimal point, that is of type float. So since the average is of type double and can be converted to float, F is the symbol that we are using for doubles and floats. So if we run this, okay, so we have 87.76. So printf rounded up the value. So uncomment this print line to compare. Okay, so we have the first one does not have any formatting and the second one has a formatting. So it rounds up the value to 87.76. Okay, so now printf can also be used in the string variable. So for example, we have a string name, let's say John Doe, and then printf using the printf. Okay. So hello percent s. Okay. So for a string, the operator is s, or the symbol for the placeholder is percent s. Let's run. Okay. So I don't have any new line in the last one. So I add new line to print the hello John Doe in the next line. Okay. So there you have it. Hello John Doe. You can also use the printf in an integer. So we have age is equals to 20. Then print it using the printf function. So for the integer, the placeholder operator is the percent %d. So for example, I am percent %d years old, and then the parameter, which is age. Okay. So let's try to run this. Okay, so running the program will have an output. Okay, so I am 20 years old. So the placeholder for integer is the \d. So the last part of our topic is about basic typecasting. So let's delete it first. So typecasting allows us to convert value from one value to another value. So basically, you can apply this in numbers. So for example, you have a integer. So let's say age is equals to 20. Then you want to use it in a variable that is type double. So let's say age d is equals to age. So if you type that value, you can see that there's no error because um, double has a higher um, level than the integer. So it means that you can uh, convert the age as int to a double. But if you want to reverse the case like this one, so double grade is equals to 98.78 and put it in a grade that is int. So we have an error now because um, we cannot convert directly double value into a integer value. So you need to have an explicit conversion from int to double. It means that you need to put open and close parentheses in front of the variable that you want to compute, then put the type, which is um, int, something like this. So there is no error now. Now let's print the values of our variables. So age d and grade I. So let's run. Okay. So the 20, since it is converted to double, now has a point zero or a decimal value. So 20.0 since it is now a double value. Now the 98.78, since we have converted it into a integer using the typecasting, we now have only the whole number, which is 98, and the 0.78 is ignored. So if you want to convert from integer to double, it is a direct casting, so you don't need to put the casting operator. If you want to convert from double to int, you need a casting operator, which is the open and close parentheses and the type that you want to compute. If between float and double, there's no need to cast. So for example, f equals to 98.9, so 2 double d is equals to f. Okay. So I forgot to put the f. So the double value, now if you type a decimal value like this one, 98.9, this by default will have a type of double. So you need to explicitly put an f so that it will treat as a float. Now since it became a float, now we can pass the value of f to d since they have the same level. So like the integer, so if you have a very long value, it can be converted or upgraded to double. If you want to do the reverse, so for example, double g is equals to 7.99999, okay, so that is double, and you want to convert it to float. So float f1 is equals to g. You will gonna lose some precision and it will cause you an error, so you need to explicitly put a typecasting operator like this. Okay. So from int to double or float to double will be upgrading the value. From double to float or double to int will be downgrading the value. So you need to have a typecasting operator if you want to downgrade the value into a much lower precision value like integer and float. Okay, that's it. So go ahead and do some practice from these examples. Again, thank you for watching and hope you check my next tutorial. And don't forget to subscribe. Thank you.